Okay. So we will also see the concept of recursion. We will also see the concept of something called as lambda functions. And after that, we will pass to the tuples. And tuples is again a very important topic in the case of Python. Okay. So now, if you remember that we were actually talking about the parameters and the arguments. So also we can pass the list as an argument. Okay. So again, if you can send any data type of argument to a function. It can be a string, it can be a number, it can be a list, it can be a dictionary, etc. And it will be treated as the same data type inside the function. Okay. So for example, if you look at this example, so let us say that we have a function called as my function, right? And we are passing something called as food. So the parameter for this function, my function, is actually what? Food. Okay. And what we are doing is we are just taking a for loop and we're iterating through this loop. Okay. So we are saying for x in food, we will print what? The value of x. Okay. So again, what is the fruits in this case? Fruits is, again, you can see it's a list. Okay. So in this list, we are having what? Three elements. One is the apple, one is banana, and one is cherry. And what we are doing is, so whenever we are calling this function, my function, and whenever we are calling this, so as an argument, we are passing what? The whole list. Okay. So list is what? Fruits. So we are passing fruits. Okay. And whenever we pass fruits, what will happen is these fruits will actually again be saved in what? The food parameter. Okay. And after we save it in the food parameter, what will happen? We will actually iterate over the food list, and then we will print what? The value of x. Okay. Someone is has unmuted himself. Rishi. Rishi, if you can mute yourself, I guess I can mute you. Yes. Okay. Okay. So let us see a demo of this. It's a very easy demo. So let me just go to my command prompt. Let me make it bigger. Let us write Python, right? So we will be greeted by this Python a shell, okay? And what we will do is we will write the define keyword. We will write my function, so my func, and suppose we are giving food as the parameter, okay? We'll give a colon. We will press enter. 1, 2, 3, 4 spaces. We will write for x in food. So what we will do here? 1, 2, 3, 4. 1, 2, 3, 4. We will print what? The value of x. Okay. So again, we are greeted by the Python prompt, so which means the definition of our function is successful. Now what we will do is we will have a list called as fruits, and in this fruits we have suppose three elements: so apple, uh, banana, and cherry, like this. Okay. And what we can do, we can call the function like my function, and we can pass what? Fruits. Okay. So whenever we will pass fruits, so what will happen here? So in every line, the apple will be printed, banana will be printed, and cherry will be printed in 3 lines. Okay. Let us check whether the same thing happens or not. So again, you can see that the same thing is happening. Okay. So again, not only variables, we can pass lists, we can pass dictionaries, whatever we like, we can pass into a function. Okay. Now, now, so to let a function return a value, we'll use the return statement. So we have already seen this example previously as well. So in the default parameter value. Okay. So let us say that this is the whenever we want to return something from a function. So till now, what we have done is we have actually printed everything inside the function itself. Okay. So what we can do here is, so we can also return a value of some computation from the function itself to the calling variable. Okay. Now let us see what do we mean by this. So let us see this demo. So again, if I just write, so we are defining a new function called as my function. Okay. And let us say that as the parameter we are passing x, we will give a colon, 1, 2, 3, 4 spaces, and we will return what? Return 5 into whatever the value we will pass as an argument. Okay. So if we do this and if we press enter, we will get back the Python. Uh, what do we say? Python prompt. Okay. And after we get the Python prompt, so let us see what we can do. So we can write print. We can write my function, and if we say 5, so we can print what? Sorry, we can print 25. Or what we can do, we can take a variable called as x, or we can take a variable called as a, and we can say a is equal to my function of 5. So now what will happen? So whatever be the value that will be returned from the function will be stored in actually a. And now if I print a, let us see what happens. It will print the actual value. This is how we can return functions from return values from the function itself by using the return statement. Okay. Now, so we have completed this slide. So let us quickly close this. Let us go to the next slide. Okay. So this is the next slide that we will study today. Okay. So the next thing that we'll study today is known as recursion. Okay. Now what is recursion? Now Python also accepts function recursion. Okay. Which means a defined function can call itself. So what is recursion actually? It means that a function can call itself, and whenever a function will call itself, we will call that as a recursive function. Okay. Now recursion is a common mathematical and programming concept, and it means that a function calls itself, and this means that you can loop through a data to reach a result. Okay. Now, very quickly, if I just see this example, it will be much more clearer to us. So, suppose we are defining a function called as try recursion, right? As a parameter, what we are passing k, right? And inside the scope of this function, what we are seeing is we will say that if k is greater than 0, so whatever be the value of k that we will be passing, if the value of that k is greater than 0, what we will do is we will just write result is equal to k plus, so whatever be the value of k, so that plus. Now what we are doing here, we are actually calling the same function once again, right? But in this case, whenever we are calling the same function once again, we are taking the argument as what? K minus 1. So whatever be the value of k, we will subtract 1 from that, and again using that same value, we will call the same function once again. Okay. And again, whenever the value, suppose the value of k is 6 in this case, so again I will check is, so value of k will be 6 obviously whenever we will call the function. So whenever the value of k is 6, we will actually check what is k greater than 0 or not. So yes, it is greater than 0. So what we will do is we will just take a variable called as result, and what we will do is we will actually add 6. Okay. So we will take 6 for the value of k, and we will do what? Plus try recursion k minus 1, which means I will again call this function using what? The value as 5. Okay. Now, whenever the value of, I will pass the value 5 as an argument, what we will do is we will actually call the try recursion function, which means now this try recursion function will actually run with the result with the value of k equal to 5. Okay. And whenever the value of k is equal to 5, I will again check is it greater than 0 or not. So yes, it is greater than 0. So what we will do, so in this result, what we will do, we will write 5 plus try recursion of 4. So again, we are calling the same function using what? The value of k is equal to 4, right? So this way, we will just have a kind of a loop, right? And whenever the value of k becomes a 0, which means it is not greater than a 0. So I will come to the else part. And in the else part, we can see that we are passing, we are actually doing what? We are saying that the result is equal to 0. Okay. And now we are actually what? Returning the result. Okay. And now, so what it will do is it will just print the value of the addition of 6 and 5 and 3 and 4 and 3 and 2 and 1. And whenever it goes to a 0, it will add what? A 0 to the actual result variable. Okay. And let us see if the same thing happens or not. Okay. So let us go to this command prompt once again, and let us say that we define the same thing. Let us say try recursion. Okay. And we will pass the parameter as k. We'll give a colon 1, 2, 3, 4. So if k is greater than a 0, so what we will do, we will say result is equal to k plus, again we will write try recursion of k minus 1. Okay. And every time let us say that we will print the value of result as well. So we will print what? The value of result. Okay. If not, if it is not less than greater than 0, so we will come to the else part. And in this case, we will say result is equal to what? 0. And lastly, what we will do, we will return the result as well. Okay. Now what? Let us see what we can do. So if I write try recursion, if I call the function try recursion of 6, let us see what happens. What happened? Oh, I made a spelling mistake. So again, we can see what is happening here. Okay. So initially, initially, whenever it is 6, it will call the 5. It will call the same function using 5. Again, that function will call the same using 4. Again, that function will call the same using 3. Again, that function will call the same using 2. And again, the same function will call the same using what? 1. Okay. Now, whenever we have 1, so obviously we are printing the result. So first it will be 1. Okay. Then again, if I go backwards, whenever 2 was called, so now it will become what? 2 plus 1, so it will be equal to 3. Right? Now again, let us go backwards. Now again, when 3 was called, so it will now become what? 3 plus 3 is equal to 6. Okay. Now again, when 4 will be called, it will become 6 plus 4 equal to 10. Right? And when 5 was called, it will become 10 plus 5 equal to 15. And again, when 15 was called, I will print what? I will actually do 15 plus 6, that will be equal to 21. So obviously I will print 21. And what do? We return the result as well. So whenever we are calling this try recursion, so it will print 21 obviously, and also it will return the result. So again, for that scenario, we can see that first it is printing 21, and then since it is returning the result, so obviously whenever we are calling this function, so obviously it will print the final value as well. So again, so we can see that we are printing 21 for 2 times in the final as the final result. Okay. So I hope I'm clear till this example. If not, kindly ask me. I'm there to help. If any one of you can confirm whether it is clear or not, the recursion part, in the chat box or by unmuting yourself. I'm waiting for an answer. Anyone? Can I get an answer, please?
Yes, sir.
Yes, I am clear. Okay.
Sir,
Thank you. Okay.
sir, how recursion uses a stack to implement?
Sorry, how recursion uses?
How recursion uses a stack for its implementation?
Stacks.
Yes, sir.
How it is using stack?
Yes, sir.
So again, stack follows the same concept of first in and last out, right? Stack.
Yes, sir.
Yes. Okay. So again, if you see the same example of recursion, so you can see that the thing that was actually inputted first, which means 6 was actually inputted first, right? Yes. No.
Yes, sir.
So again, you can see that actually 6 was input first, but actually what is happening is it is actually added at the last. Yes or no?
Yes, sir.
So again, that is the same concept that a stack uses. So the variable that comes inside the stack at the first will be executed at the last. So similarly, this the same thing happens here as well. So the variable, the argument that we are passing to the recursive function first will be actually added in this example at the last. Am I clear? Yes, no?
Yes, sir.
Okay. Okay. Let us move forward then. Okay. So we will have the lambda function now. The lambda function is a special function and it is an anonymous function, right? Now, what is anonymous? Anonymous means that a function that does not have a name. Okay. So till now, whatever function we have studied, we have seen that whenever we are having a function, we are using the def keyword and we are giving the name to that function, right? But again, if I want to implement a function that will have no name, so we can use something called as what? A lambda function. Now let us understand how a lambda function actually works. Okay. Now, a lambda function can take any number of arguments, but can only have one expression. Okay. So again, in the syntax that we have here, we can see that we are using a special keyword called as lambda, right? And we have set arguments, so which means it can have suppose three arguments, so it can have a, b, and c, right? But again, whatever number of arguments it has or it can have, it will only have what one expression. Okay. Now let us see an example, and it will be much more clearer to you. So again, if I want to add 10 to an argument a and then return the result, right? So we can use a lambda function. Okay. So again, in the default default function definition that we have studied till now, we would have written what def add, for example, right? And then as a parameter, we could have passed what a, right? And inside the scope of that function, we would have written what that return a plus 10. Okay, so we could have written this, and what we could have done, we could have come out of the function, and then using a variable called as x, we could have called that function, and whatever the value that function returned would now uh, be stored in what x, and now we could have printed x, right? So this was the normal scenario that we could have done. Okay, but in the case of lambda function, so instead of defining a special function for this, we can just use an anonymous function and we can do the same. Okay, so here you can see that we are just saying that x is equal to, so x is a variable, and we are saying x is equal to what lambda a. Now what is this a? A is the argument, as you can see in the syntax. So whenever we have the lambda keyword, so the first thing will be what arguments. So lambda argument is a, and we can write was what a plus 10. Okay, so whatever be the value of a, 10 will be added to that. Okay, and now since it does not have a name, what we can do is whenever we are calling this function lambda function, so we can just call what the variable that is actually there whenever we actually define the function. So here you can see that we are calling what we are calling actually x. Why? Because x is the variable, and then we are passing 5 as an argument. Okay, so whatever argument that we passed here will now be stored in a, right? And what it will do is it will just add 10 to that, and it will return it to the x. And whenever we print x, obviously we will print what 50. Okay, this is the first example. The second example is, as we have said earlier, that it can have more than one arguments. So again, in the second example, you can see that actually we are taking what two arguments, a and b, right? And what we are doing is whatever the two arguments are there, we are just multiplying them, right? And again, we are storing the same thing in x. So obviously, whenever we want to call this lambda function, what we will do, we will actually call what x. So we are actually calling x, and we are passing what 5 and 6. So 5 and 6 will actually be stored in what a and b, right? And similarly, for the last example here, you can see that we are actually having three arguments or three parameters, right? And what we are doing is we are just adding up all the parameters, and again we are saving it in x. And whenever we want to call this lambda function, what we are doing is we are actually calling x, and we are passing what these numbers, and these numbers 5, 6, and 2 will be actually stored in what a, b, and c. Okay, so let us see these examples one by one, and let us see whether the same thing happens or not. Okay, so suppose we have x is equal to lambda, we have a, and we will have a colon, and we will write the expression. So a plus 10, right? Now what we will do, if I just write x of 5, you can see that we are actually printing what 50. Okay, now again, if I do the second example, so again if I write a comma b, right, and let us say we will just multiply a and b. Okay, and now whenever we call x, let us pass 2 and 3. So obviously the result should be equal to 6. Okay, and lastly we can see that we have actually three arguments here, a, b, and c. And what we have done here, we have just added a, b, and c. And let us see whether the same thing happens or not. So if I just pass x 1, 2, 3, so it will be equal to 6. So obviously let us check it, and yes, it is equal to 6. So again, we can use the lambda function to actually make functions or define functions that does not have a name. We can actually define what anonymous functions. Okay. Now, now, why do we use lambda functions? So the power of lambda function is better shown when you use them as an anonymous function inside another function. Okay. So now let us see this example. Listen to this example very carefully, and let us understand what happens here. Okay. So suppose we have a function called as my function. Okay. And what is the parameter here? It is n. Okay. And what will this function return? It will return lambda a and a into n. Okay. Now what does this mean? It means that whatever be the value that we will pass in my function, that is n. So what we will do is we will just multiply that n with something, with a variable called as a, or with an argument called as a, that we will pass in some different fashion. Okay. Now, so after defining this, let us understand what happens. So what do we do here? So if I just write my function of 2, so obviously what does this mean? It means that 2 will be actually stored in what? N, right? If I write my function of 3, so obviously what will it mean? It will mean that 3 will be stored in N, right? Now, what we have seen earlier, that we could have written what? Let us see. Just a second. Okay. So we could have written, instead of this return, we could have written, for example, r equal to this. Yes, no? Please respond. Yes, no? Anyone? Yes, no?
Yes, sir.
Okay. So we could have written r equal to this. Okay. And this means, whatever we have said earlier, that if we want to call this anonymous function, we could have written r of something. Suppose we could have written r of 3, right? So obviously, if we could have written r of 3, so obviously this means that the value of a now should have become what? 3, right? Now, let us just try and understand this very carefully. So in this scenario, we have not written r equal to lambda, whatever is the expression. So which means if I return this lambda value, so obviously it means that I will have to have a variable for that. Now, obviously, if I say that this variable, my doubler is the same variable, or my triplet is the same variable, would you agree with me? Which means what is happening here? So if I'm passing my function 2, so 2 will be actually stored in what? N, right? Now, I am returning what? I'm returning the value of lambda a of a into n. Okay. So which means, so whatever I am returning will be stored in a variable, right? So what's the variable? My doubler and my tripler. Okay. Now, if this lambda function is actually stored in my doubler or my tripler, so again, if I want to call this lambda function, so obviously I will have to use the variable names. So what is the variable name? It is my doubler or it is my tripler. Okay. Now, so if I call my doubler and if I pass 11, so obviously where will this value of 11 go? It will go to this A. Yes, no? Yes, no? Anyone? Yes, no? Yes, no? I'm waiting for an answer.
Yes, sir.
Okay. Again, if I pass 11 to my tripler, obviously this 11 will go to what? A, right? Now, what does this mean? It means that if I pass 11 to A, what will I actually return? So if I print my doubler, what will be returned? It will return what? 11 into 2, that is 22. Or if I call my tripler, it will return what? 11 into 3, that is 33. Yes. Okay. So let us check whether the same thing happens or not. Okay. Suppose we are defining my function, right? And we are giving the parameters n. We will give the colon, and we will just write return lambda a colon a into n. Okay. And what we can write? We can write my doubler is equal to my function of 2, and I can write my tripler is equal to my function of 3. Okay. Now what we can do is we can call my doubler, and we can pass 11. So if I pass 11, the value should be 22, and it is 22. And if I write my tripler, and if I pass 11, it should be 33, and it is 33. Okay. So I hope I'm clear till this. If not, you can ask me the questions. Okay. I will give you 10 seconds to ponder on this and ask me the questions. Okay. I don't think you have questions, as well as I don't think you guys are interested. So, anyways, uh, my job is to teach. Your job is it's your choice to listen or not to listen. That is completely up to you. But again, I will continue forward. And again, if you have any problems, you can ask. Okay. So let us come to the some other topic that is called as what? Python modules. Okay. Now this is again a very interesting thing that we can do using Python. Okay. So again, a file containing a set of functions you want to include in an application. So what is this? This is called as a module. So if I want to define a module, it is nothing but a file that contains a set of functions that I can include in my other programs. Okay. Now, so if I just go to my command prompt and let us show you some examples. Okay. So first, let us exit this Python shell. I will write clear, okay, CLS. Okay. And what we can do here, we can write notepad.exe, right? And we can write something called as mod.py. Okay. So if I go to this mod.py, what I can do, I can write define greeting, right? And I can write name as a parameter. I will give 4 spaces. I can print hello, and I can write what name. Okay. As well as what I can do, I can define a dictionary. So I can write person1 is equal to. So the first key is suppose name, and the name is, for example, John, right? And the next key is suppose, for example, age. So suppose the value is 36, and we have the key as country, and suppose we say that the value is Norway. Okay, and let us save this as mod.py. Okay, now let us understand what we can do with this. So again, we have saved a file called as mod.py, right? And here we have a function, and we have a dictionary. Okay, now let us close this, and let us open Python once. Okay, so what I can do is I can write import mod. Okay, so I've imported whatever we have written inside that mod.py module. Okay, now what we can do, we can write mod dot. So I have a function there, so I can write mod dot greeting. So greeting is the function, and in this function, in that function, if you remember, we actually were passing the name as the argument or the parameter. Okay, so what I can write, I can write im. Okay, and if I write im here, if I press enter, you can see that it is printing what hello im. So which means it is actually executing the same thing that was there in the function call in the mod.py file. Okay. Also, what we can do, we can write a mod dot person one, right? And obviously, person one is a dictionary. So what I can write is, I can suppose I want to find out the name of whatever is stored in the dictionary. So obviously, we will use the square bracket method, and we will just give the value of the key name. And if I write this, you can see that it's printing John. Okay. Again, if I want to write the age of John, okay. So again, you can see that it's printing 36. Okay. Am I clear with the examples? Yes, no?
Yes, sir.
Okay. Next. So again, we can use an alias. So what's an alias? Let's understand. So instead of writing mod, I can also write import mod as anything. Mod as, for example, college. Okay. So now whatever was there in mod will be stored as college. Okay. So that's an alias. So again, I can use the as keyword to import the same thing as an alias. Okay. And again, if I write college dot person one of suppose country, it should print what Norway. Okay. Now, again, like this, Python also has some inbuilt modules as well. So whatever we have seen till now are what the custom modules that we can create. Okay. So similarly, Python will also have some inbuilt modules as well. So suppose one such module is called as platform. So if I write import platform like this, okay, right? And again, inside this platform, we can have another function called a system. Okay. So now if I write platform dot system, you can actually see that it will tell us that what OS we are using. So again, if I just press enter, you can see that yeah, we are actually using what? Windows. Okay. And also we can have a dir function, dir directory function that can actually list what functions are actually there present inside the modules that we are importing. Okay. So again, if I'm importing the platform module, so what I can do is I can write dir of platform. So if I write this, so you can see it will be a list that will actually show us that what are the functions inside this module called as platform that we can use. Okay. If I do the same thing for our module, so it is mod. So again, you can see that these are the default ones. Okay. And again, lastly, we can see that we have a function called the greeting inside this, right? And also we have a dictionary called as a person inside this. Okay. Now, again, what we can do is I can only choose to import certain parts of my module. So in my module, in our module, we had two things. One is a function called as greeting and one is a dictionary called as person. So what we can do is, suppose we want to just call the person one dictionary and not the greeting function. So what we can do? We can write from mod import person one. Okay. So if I just write this, so in this scenario, what we can do, since we are explicitly importing person one, so I can write mod dot person one of name. I can write this as we have seen previously, or since we have explicitly called person one, so I may or may not write this mod thing. I can only write what person one, right? And I can just print what the age. Okay. But in the previous scenario, if we were actually not doing from mod import person one, then we always have to write mod dot person one. Okay. Now, acha, if in this scenario I have imported only person one, right? Let us check whether acha, let us close this first. Okay. And now let us write Python, and I will write from mod import person 1 only. Okay, and let us check whether greetings works or not. Okay, so if I write mod dot greeting, and if I write IEN, now you can see that it is not defined. Okay, so again, uh, so using the from keyword, whatever we will actually want to import, only that thing will be imported, not the whole thing. But if I don't use the from keyword, if I just write import mod, so what will happen in that case? Everything will be imported that is there inside the module that we have created. Okay. Now, so am I clear till this one? This was all with the functions. Okay. Am I clear till this one? Yes, no?
Yes, sir.
Okay. Now, we will move to something called as Python tuples. Okay. Now, what's a Python tuple? Let's understand first. So, tuples are used to store multiple items in a single variable. Okay. So, tuples are actually what? They are used to store multiple items in a single variable. Okay. Now, obviously, you can say that, okay, to store multiple items in a single variable, we could have used a list. Okay. But why actually we are using tuples? Okay. See, we could have used both, but again, fundamentally, tuple and list are different things. And we will tell you at the end of this tuple session that when do we use lists and when do we use tuples, and what's the advantage of a list over a tuple and what's the advantage of a tuple over a list. So we will say we will discuss all these kind of things. But before that, let us understand what a Python tuple actually is. Okay. So again, a tuple is actually stored used to store what multiple items in a single variable. Okay. Now, tuple is one of the 4 inbuilt data types in Python. Okay. Just a second. Okay. So tuple is one of the 4 inbuilt data types in Python used to store what collections of data. Okay. Now, what are these data? What are these? One is a tuple. The other 3 are list, set, and a dictionary. Okay. And we have seen dictionary and a list. We are seeing tuple, and we will be left with set, and we will see that in the later half of the session. Okay. Now, a tuple is actually what? A collection which is ordered, unchangeable, and it allows for duplicates. Okay. Now, obviously, what is ordered? Ordered means that when we say that tuples are ordered, it means that the items have a defined order, and that order will never change, right? Which means the order in which we will insert elements into a tuple, that order will always be maintained, right? So till now we have studied list, we have studied strings, we have studied dictionaries, we are studying tuples. In every case, we have seen that the data structures are actually ordered in nature, right? But you can have a question that, okay, if every data type that we've studied till now is ordered, so why do we have to write ordered every time, right? We have to write ordered every time because the data structure that we will study after this, that is sets, we can see there that it is not an ordered data structure, which means the order in which we will insert elements into a set, that order will not be maintained by a set. Okay. So, but for the other data types, that is the tuples, the lists, and the dictionaries, we actually have what they are actually ordered in nature. Okay. The second thing is what it is unchangeable. Okay. So in the case of strings, in the case of list, in the case of dictionaries, we have seen that we can change certain elements in a list or a dictionary. Okay. But whenever we are talking about tuples, it is actually unchangeable, which means once a tuple is created, we cannot change any value inside a tuple. Okay. And also it allows for duplicates, which means since the tuples are indexed, so which means since they are ordered, they can have items with similar value, same value. Why? Because the values will not be used to actually search. The indexes will be actually used to search. And whenever we have different indexes, so in different indexes, we can have what same value. Okay. Now, again, a tuple is actually written with a round bracket. Okay. So in the case of dictionary, we have seen that it's written with a curly bracket. List are actually written with a square bracket. But in the case of tuple, we can see that it is actually written with by a round bracket. Okay. Now, okay. So first and foremost, let us go and define a tuple. Okay. So let us say my tuple. We will use a round bracket. Suppose we will give three elements: apple, banana, and cherry. The same things. And cherry. Okay. And if I just print the type of my tuple, we can see that it is of class tuple. Okay. Also, we can find out the length of the tuple using the len function. So again, if I just write the len function, and if I write the tuple name, that is my tuple. Okay, sorry, I made a spelling mistake. So again, you can see that the length is for 3. Okay. Now, again, I can create a tuple with only one item. Okay. Now, if I just write by logic that if I have another tuple, if I write another tuple, and if I write kiwi here, so this is by logic, which means it should have a round bracket and it should be a valid element. Okay? So again, we are using a valid element called as a string, and we are using what round brackets. And if I just press enter on this, and now if I print the type of another tuple, you can see that it is not a tuple, but it's a string. Okay. So obviously, if I just use our logic, so with our logic, we cannot define a tuple. So if we are wanting to define a tuple that has only single element, so what we will have to do is we instead of writing kiwi in inverted commas and then giving a round bracket, what we have to do is we will have to use a comma. Okay. So after we use a comma and now if I press enter, and now if I print the type, now you can see that it has been converted into what a tuple. Okay. So obviously, what does it mean? It means that whenever we want to create a tuple with a single element, we will have to use an extra comma to make it to make the compiler realize that it's a tuple and not a string. Okay. Now, the tuples can be of any data type. Okay. So again, in the first tuple, you can see that we are actually using all strings. In the second tuple, we can see that we are actually using what all integers. In the third tuple, we can see that we are actually using all Boolean values. Okay. And also, in another example, we can see that a tuple can have multiple data types as well. So again, in this tuple, we have the string first, we have the integers second, we have the Booleans third, we again have an integer, we again have a string, and so on. Okay. Now again, if I just print the type of my tuple, we will actually get that it is belongs to a class called as tuples. Okay. Now, it is also possible to use the tuple constructor to make a tuple. So again, in the case of lists, also we have seen in the case of dictionaries, also we have seen that if I just use the list keyword or list constructor or the dictionary constructor, we can create dictionaries. So again, the same thing is possible with the case of tuples as well. So again, instead of just writing, giving brackets and giving the names, we can also write what tuple and then give brackets and then write the names. But important thing to remember here, so I have also written that very carefully that please note the double round brackets. Okay. So in the case of list, we have seen that we have actually used a single round bracket. In the case of dictionary, also we have seen that we have used a single round bracket. But since tuples are actually round brackets, so again for this we actually have to use what double round brackets like this. Okay. So again, if I just go to this and if I write my tuple equal to, and if I just write tuple and we give a single round brackets and we write apple, banana, and cherry. Let us see what happens. Let me copy this first. Okay. See, I have given a single bracket, and you can see that it is giving me an error. But now, if I do the same thing, but if I give a double bracket like this, you can see that there is no error. And if I print the type of my tuple once again, you can see that it is of class tuple. Okay. Also, you can access tuples item by referring to the index number inside what? Square brackets. Okay. So again, if I just want to see what is there in the index 1, so I will write what? My tuple of what? 1. So we can see that there is banana. Okay. Also, we can use the negative indexing as well. So which means if I want to find out what is the last variable of last element of my tuple, so I can use square brackets and I can use -1. So cherry is the last element of the tuple. Okay. Also, we can also have ranges. Okay. So if I just to this my tuple, if I add 2 to 3 more elements, so if I just write my tuple equal to, let us give these elements as well as let us give some more elements. Guava, we can have cherry. So since it allows for duplicate, so we can have elements of the same name, right? And what we can do, I can write my tuple. I can use a range. So I can use 2 till 5. So again, you can see that it is printing from 2 till 5. Okay. And also, since we have this range, we can also have the increment. We can also custom define the increment variable as well. So which means if I just write my tuple, and if I don't give the starting and the ending index, so I will give 2 columns. Okay. And if I write 2, so 1 is by default. If I write 2, again, you can see it is printing apple. It is leaving aside banana. It is printing cherry, leaving guava, and then again it is printing what? Cherry. Okay. So these things are actually possible in the case of tuples. Right? Now, so again, to determine if a specific item is present inside a tuple or not, we use what? The in keyword. So now again, in keyword we have seen earlier as well. So again, if I see this example, we have a tuple with 3 elements, and if I write if apple in this tuple, so obviously I will print what? Yes, apple is there in fruits tuple. Okay, so again we can use what? The in keyword to determine whether a specific element is present inside the tuple or not. Okay. So again, we will not show. We are not going into this demo. So this is actually very easy. The second thing is once a tuple is created, you cannot change its values. Okay, so this is the main thing that we have studied whenever we started with tuples. Okay, so one of the tuples are actually unchangeable in nature, which means once a tuple is created, you cannot change the value of a tuple. Okay, but now if I want to change it, there is a workaround. Okay, so what's the workaround? You can see that first and foremost we are defining the tuple, right? And after defining this tuple, if I want to change it, what we are doing is we are actually converting it into a list using what? The list constructor, if you remember. Okay, so if I just convert it into a list, now what I can do is I can just add something to this list. Okay, and what I can do, I can convert it back into a tuple using what? The tuple constructor. Okay, and now I can print the tuple. So let us see this example. So if I go to the command prompt, if I have my tuple, so if I print my tuple, we can see that there are 5 elements. Okay, and what we can do here, we can just convert this into a list. So if I write x equal to list of my tuple like this. So now x is what? A list. So if I print x, you can see that everything will be printed, but it is actually inside a square bracket. So it's a list actually. Okay. Now what we can do here? We can write x dot append key for example. So which means I will be appending to the end another element called as key. And now if I print x, you can see that we have added one thing called as key. Now what we can do is we can convert this back into the tuple. So I can write my tuple is equal to tuple of what? Of x. And now if I print my tuple, you can see that again we have it's a tuple because it is inside the round brackets, and we can see that actually we have inserted a new element called as what? Key. Okay, so again tuples are unchangeable in nature. We cannot add anything into the tuple, but what we can do is we can convert it into a list, and then we can add it and then convert the list back into a tuple, and then we can print it. Okay. Okay. So again, uh, Okay, so we have seen this example, the append method. Okay, one more thing is possible. That is, if I have this tuple, right? So what we can do is, so if I have this tuple and supposing another tuple, if you remember, we had created another tuple. So this is TV actually. So what we can do is, we can write my tuple plus equal to another tuple. So if I just write this, again you can see what is happening. So if I just print my tuple now, again you can see that actually we have added a kiwi, which means we are not actually adding it, but we are actually adding two tuples together, and then we are printing what the result. Okay, so again we can do this as well. Okay. Now to remove elements from a tuple, what we will do, we will first convert it into a list and then we will remove elements. Okay, so if I just show you an example, so if I have my tuple, so again let us convert this into a list first. So let us convert this into a list. Okay, right? And now suppose I want to remove the element called as kiwi. Okay, so if I just write x dot remove of what kiwi, so which means if I now print x, you can see that the last kiwi has been deleted. And now what I will do is I will just convert this back into the tuple. So I can write my tuple is equal to tuple of x. And now if I print my tuple, you can see that one kiwi has been deleted. Okay. And also lastly, what we can do, we can have a delete keyword to again delete the whole tuple, right? So let me just copy this first and then we will delete it. Let us copy this. And now what I can do, I can write del my tuple, which means now the whole tuple has been deleted. So now if I print my tuple, you can see that it will give me an error. Why? Because the my tuple variable is not inside the memory anymore. Okay. Okay, so it's already 5:58. There's no point in continuing further. So we'll stop here for today. And what I will do is I will stop the recording first. So let the recording continue. So what I will do is I will actually paste your attendance form in the chat box. And also I will give you the Google Classroom code as well in the chat box. So kindly join the Google Classroom as well. Give the attendance. So if you don't have any problems for today's class, you can leave the meeting and give the attendance. If not, if you have problems, you can stay back and ask me the questions. Okay. Thank you. That will be all for today.